Hello class, this is a video tutorial on Introduction to Networks. A network in the mathematical sense is any group of interconnected objects. So we might have a city road network where we have different cities. I've drawn one here. It's not drawn to scale, obviously. We could have a Wi-Fi network. We have the modem connected to the router. And from the router, it connects to the different devices that we have. We could have a Facebook friend network where we could say that you are there in the middle. All your friends are connected around you, like there's a big web here. And each friend might have another friend. And it just keeps going off into however many people there are on the network. And I did some more research, and it turns out even AI programming also follows this idea of a network. Had to learn a little bit about this. You have the inputs, and from those inputs you have to teach your AI what their response should be. And from those responses, you give more responses, and you can actually include as many hidden layers as you like, and eventually you get an output from your AI. But the main idea that I'd like for you guys to take is that a network is any sort of interconnected object. Now, here's the important terminology that we need to learn. I'd like for you to write them down. The terminology we have is a network diagram. It's just a visual representation of the network. So these four here are network diagrams. You might also hear, and I'll interchange between the words, between network and graph. These two things mean the same thing. A vertex or a node is the dots or points on the graph and can be almost anything. So going back up to here. So these are, hang on. One is called a vertex, multiple of them. I've circled the vertices, and in this graph, the nodes or the vertices represent a city. In this Facebook friend network, the nodes or the vertices represent people. In this one here, the nodes or the vertices represent devices. And I'm unsure what these nodes represent. I think it's programming of some sort. So a vertex is the dots on the graph. The edge, well, it's just exactly what you think it is. It's the line connecting the vertices. Edges can intersect or overlap. They can curve, and multiple edges can connect to the same nodes. So take, for example, these two vertices. Notice how they have two edges connecting them. Notice how these two edges are curving. But also notice that this edge connects to nothing. This edge technically should not exist. So I'm going to erase it. There's what's known as a loop. It's an edge that starts and ends at the same node. So here's an edge. It leaves, and then it comes back. That is called a loop. We have what's known as a directed edge. It's an edge indicating the allowed travel by use of an arrow. So for example, this might be an intersection or road network. So these edges here that have arrows pointing up. This could represent a one-way road. Here's another one here. Edges that are undirected means travel can go both ways. So this road can go this direction, or it could start here and go in that direction. Whereas this one here can only go from this node up to this vertex. Another funny idea I had to represent this idea of a directed edge is when you follow someone on Instagram. So a follow can go one way, but if they don't follow back, it remains a directed edge. Weighted edge. Weighted edges is just placing a value on an edge that may indicate almost anything. It could be cost, distance, time, capacity, etc. So I just made up this little flight map here. So we could put the cost in Australian dollars on each of the edges. So this graph represents all the flights from Sydney to Manila, $550. From Manila to Tokyo, $75. And I think you get the idea. We could make the edges weigh the time taken. So from Sydney to Manila, it's about 6.5 hours. From Sydney to LAX, it's about 12 hours. These numbers are made up, by the way. I'm not too sure if these are correct. Or it could be passenger flight capacity. It could mean anything. Okay. So for now, this is all the terminology that I'd like for you guys to understand and remember. And I hope to see you in the next video.